And we'll do question number 4. It says using graphing technology. I'll show you how to use graphing technology. We'll also look, because you won't have a graphing calculator on your exam, we'll also look how to solve it algebraically, because that's how you would solve this on your exam. So algebraically. Anytime you have a square root in an equation that you're solving for, are you okay if I change this side to x minus 6 instead of negative 6 plus x? How do you get rid of a square root sign? You square. So when you're solving an equation with a square root and there's an x inside, this is something you learned in grade 11. You needed to isolate that square root, so the square root's all by itself now. And now I can square both sides. Now squaring a square root, the reason you isolate it is because squaring, wow, there's a good plus sign. Squaring a square root cancels out the square root. You have to be careful on the right-hand side, because when you square that side, you're going to have to FOIL. You would get x squared minus 12x plus 36. So we start by squaring both sides once that radical is isolated, so that you can get an equation that doesn't have a square root anymore. Now we analyze our new equation. What kind of equation is it? It's a quadratic function. How do you solve a quadratic function? You make one side equal to 0. So 0 equals x squared minus 3 minus 15x, subtract 2, plus 34. And although this one might look like you could factor it, because 17 times 2 is 34, and that seems to make 15, it actually doesn't work to factor. Because either you would need negative 17 and negative 2, which doesn't make 15, or positive 17 and positive 2, which doesn't make 15. So the only way you can solve a quadratic equation which you can't factor is with the quadratic formula. So solving this with the quadratic formula, x equals negative b plus or minus the square root of b squared, 15 squared, 225, minus 4 times a times c over 2 times a. $15 plus or minus $225 minus 4 times 34. So you'd still be allowed your calculator here. Now, because there's a plus or minus, you get 12.2 as one answer. And 2.78 as a second answer. The last thing with a square root equation is you have to check if they actually work. So you would have to plug it back into the original equation and see what you get. In this case, I'm going to tell you that plugging in one of them, okay, just sort of rough estimate. If I plug in 12.2, if I just sort of estimate that at 12, 3 times 12 is 36 plus 2. I'm going to get the square root of 38. Negative 6 plus 12 is going to give me 6. Is the square root of 38 about 6? It's pretty close, right? Because square root of 36 is 6. That one works. But if I try, so I'm going to put a little check mark by this one. If I try 2.78, plug in 2.78, I'll show you the shortcut of how I know that this won't work. Okay? Square root of a positive number is always positive. So if I put in 2.78 on the left-hand side, I'm going to get square root of close to 11, and that's going to give me a positive number. But if I plug in 2.78 on the right-hand side, negative 6 plus 2.78 will be a negative number. A positive number never equals a negative number. And so, algebraically, I know this one doesn't work. How can we use, again, a graphing calculator is very nice because it gives us a way of checking to see if we got an answer right. So how can we use a graphing calculator here? Well, you could type the left-hand side into y1, the right-hand side into y2. What would that look like? Square root of 3x plus 2 into y1, and negative 6 plus x, or x minus 6 in y2. If you had a standard window show up, my blue graph and my red graph don't quite intersect on the screen. So I go to my window and say, let's go up to 20. See if then they graph. Yes, the graphs intersect. So I can go second, calculate, number 5. Where do they intersect? Enter, enter, enter. 12.2. The same answer that we got algebraically. So questions for this one, where you can check with your graphing calculator but try to do it algebraically, is question number 9.